everyone, welcome to the first video of this YouTube channel called Mechanical Buzz. So this channel is all about dedicated for mechanical freaks like me. So we will talk about mechanical stuff here in this channel. So if you are trying to get updated and get tuned, wanna stay tuned with mechanical stuffs, please hit the subscribe button and the bell icon to get update and notifications. So today we will talk about a four-stroke petrol engine. So before that, we will I'm not gonna describe or demonstrate or talk about conventional petrol engines, how the four strokes work, intake, compression, power, and exhaust. Rather than I will try to make you explain or make you understand from different specs and the science behind of this petrol engine. So let's go. So the first thing is that the questions which will come in our mind is what is engine. When we say or when we heard the name engines, some kind of machines and cars and everything just come up and pops up in our minds. But actually what is the term of engine and why we call it engine, and actually what it is engine. So we have to know that. Basically, right now I'm talking in this video, and as a human beings and as an animal being, we have to walk, eat, sleep, and do a lot of things. We do these things in our movement that we do in our day-to-day life. We get energy from our food. We need energy to do work. As like that, machine needs energy, and thus machine do work. So that's why they need energy to do work. Without energy, no work can be happen. So like that, engine is a machine which actually converts heat energy to mechanical energy, or precisely if you say that chemical energy to mechanical energy. Actually, it's a machine which just converts the form of energy. It doesn't generate any energy, because the law of energy conversion says that no energy can destroy or can be created. So the whole entire energy system is, what we can say, we can't destroy or we can't create any new energy. So whatever, engine doesn't create any energy. Engine, rather than it can only can transform the forms of energy, as it is just from chemical energy to heat, through heat to mechanical energy. That's what we just run cars and pops up lights and fans by generator. So whatever. So we will talk about today four-stroke petrol engine. Before that, we have to be familiar with the nomenclature or the basic terminology of an engine. So this is typically not a diagram of an engine. Rather than we can say that this is a diagram of a cylinder and a piston, as because the principal objectives is to create or transfer energy from chemical form to mechanical form, and what it is happens by these pistons and the cylinder. So I draw it first. Later on, the next videos, we will actually gonna understand what are the other functions and other important parts of an engine. So as to describe the principle of an engine, we have to draw this. Before that, we have to understand three things very carefully. The first one is ignition, and second one is combustion, okay, and the third one is explosion. So we're very familiar with this word explosion, because this word is, this word has uses in our day-to-day life. So as you can see here, three words that I've written: ignition, combustion, and explosion. So I'm going to make you understand these three words basically with these matches. And okay, so you can see a matches here in my hand, and I have written here the first word is ignition. So ignitions mean, to burn up any object or to create fire. We need to ignite something. Ignite means the preconditions, or we can say that the state before anything burns. So the state before anything burns. So consequently, the state before anything combustions. So burning is said, as in chemistry, it is said combustions. Anything that burns happens a combustion reaction. That is anything that burns is a chemical reaction, and that reaction is called combustion. We will talk about it couple of minutes later. So we have to understand the ignitions. Now if I just try to make fire, or I have to make this fire through the matches by just simply rubbing it. And when I will rub it, before it will get totally it will get fire, or it will get light up, it will have a little spark on it, and that spark, creating that spark, is called ignition. So you can easily understand that ignition is something that before anything burns, there's a spark occurs, and that the creating of a spark is called ignition. So I will show you that how it's happened. If you look, it's very closely. Okay, it's popping up, and before it just makes something, you all have just have noticed is that now it's burning, right? Now what's happening is that I have to move it, or I can't just, I may have burned my finger. Okay, so what happened actually before the match got lighted, or before it just burned on, that moment is called ignition. Before anything burns, when a spark occurs, that called ignitions. And after that, when anything burns, is called combustion. Now if there is combustions, there must have to be an ignition, because without ignition, there such no combustion can be happen. But what is the term here? The explosion. Explosion is something when the combustion has some power to explode, something like that. If we explosion, explosion not always has to be with combustion actually, because if you just booms up a balloon, it's called an explosion. Explosion is something that which just expose any static form of energy. Okay, like a bomb have exploded. So if you light up any LPG tank or any CNG tank, it will explode, right? So inside the cylinder, what you can see here, inside the cylinder of an engine, these three things occurs, and for these three things we can actually convert chemical energy into mechanical energy. Yes, friends, as we know that this is a petrol engine, so we have to, sorry, so we use petrol as a fuel. Okay, we use petrol as a fuel, so this stuff has to be burned. Okay, so to burn anything you need air or oxygen. Okay, so here in petrol you have hydrocarbon, and from here you have oxygen. That's what it make a combustion. That's what will actually comes up, byproduct comes up, carbon dioxide, water. Okay, sometimes carbon monoxide also. So this is a chemical reactions, and this reactions is called actually the combustion. Okay, anything that has hydrocarbons here, one carbon and hydrogen, and will burn with the help of oxygen, is called, the process is called combustions. As like that, inside the cylinder of an engine, we do actually the combustion process inside the cylinder. We send petrol with the air, and inside the cylinder, that ignition combustion occurs, that means this chemical reaction is gonna happen inside this cylinder. So let's move on to the working principle of this engine. So we have fuel to burn, okay? So inside the fuel, okay, you have chemical energy, okay? Yeah. The chemical energy in the form of, fuel, that's what we're gonna call it as a petrol, okay? So we just turn we just convert this chemical energy into mechanical energy, okay, by the help of this engine. But that's how, as we have studied before, ignition, combustion, and explosion. The help of explosion, here is the piston which just go up and down like this injection runs here, like up and down, it pops up and down like this. Here is the piston that's ups and down inside the cylinder. When explosion happens inside the cylinder, then the piston receives some pressure, high pressure, and a thrust, and with that thrust, it's just uh, comes comes down very quickly, and with that thing on, here is a part, it's called connecting rod. This connecting rod is create a pressure or thrust on this crankshaft. So crankshaft is anything that rotates, okay? So here's two kind of movement. We can see that one is reciprocating or linear motion, and another is rotary motion. So basically, after the explosion occurs inside the cylinder, then the piston comes down, and with the help of these connecting rod like this, okay, in this motion, the piston ups and down, it goes ups and down, and the connecting rod, what is just transfer that motion from linear to a rotation. So that's how the mechanical energy comes on from that engine. So now we will see that how this happens. Actually, there are 4 strokes, and before that we have to understand the stroke. So stroke is anything inside a cylinder. There's 2 points, the topmost, the points, and the uppermost point where the cylinder, actually the piston can reach, and above that point piston cannot go further. So that point is called TDC, and the abbreviation is elaboration is top dead center. Means from that center the piston can't go further. And simultaneously, in terms of when the piston will comes down, when it will go up and then it will comes down, when it will comes down, there is a point that the piston cannot down furthermore. So that point is called bottom dead center. Now this bottom dead center is measured by the piston head. I mean, you can't measure with the bottom, or the lower portion of the piston. You have to measure it from the topmost of the piston, which is here, this one. So if this portion of the piston reaches to the topmost point, it's called TDC, and if it reaches to the lower, or what we can say the bottommost center, it's called a BDC here. So the distance between TDC and BDC is called a stroke. When a piston travels from TDC to BDC, it's called one stroke happen. Either you can say that if a piston travels or move from BDC to TDC, again one stroke is going to complete. This is something like that. If any particle is moving from point A to B or B to A, if it's have moved once at a time, then one stroke happen. So that's why here 4 different pictures of the same cylinder, because there are 4 strokes and 4 stages of an engine. So the first stroke, what happened here? Here's 2 parts. What is called intake valve and exhaust valve. What they do actually, they just by the sequence of time, and in the right time they get opens or close, or they will let air and fuel to enter the cylinder, or will let the air the burnt gas out from that cylinder. So what happened in first stroke is called intake stroke. The piston goes down from TDC to BDC, and when it goes down, what happened actually, a vacuum created inside the cylinder. Like this. This is a cylinder, and inside it's a piston, suppose that, and if it comes down, it will take something, it will take some charges. It can be air, or it can be some water also, whatever the fluid it is, it will take it inside of it, because the negative pressure or the vacuum created inside the cylinder. It's like that. When it will comes down, then here a vacuum created, and the intake valve here, which will let anything to inside to enter the cylinder, will get open, and the cylinder will suck up air from the environment and from the atmosphere. And when the air will come, the air will take some fuel and will mix it, and will enter by the help of the vacuum pressure inside the cylinder. It will enter it until the piston reaches to the BDC. Okay, and after that, the second stroke, what it is, we can see here, compression stroke, is the name is kind of like that, it will compress something, right? So in this stroke, both intake and exhaust valve will get, remain closed. It will be closed properly, fully, and those air and fuel mixture, remember that the air and fuel always just get mixed and then enters to the cylinder in terms of petrol engine. Okay, so after the intake stroke, there are some intake charges like air and fuel will get trapped inside the cylinder, and the piston will move from BDC to TDC, and when it will go, it will compress that air and fuel. Okay, it will compress. Like in compression stroke, you see that there's something inside here, and it will compress the air fuel mixture, whatever it is here inside the cylinder. And that's what happened actually. Magical things happen when it moves from BDC to TDC. When it goes to BDC to TDC, it compresses the air fuel mixture, and some temperature rises inside the cylinder, as because the volume of air fuel mixture goes very small and small and small, decrease and decrease and decrease, and pressure increases. As the volume decrease and pressure increase, the temperature increase also. And after that, when the piston reaches to the TDC, then the compression stroke is over. As I have said, that stroke is to move from TDC to BDC, either BDC to TDC. And now going on the third stroke here, as you can see here, that a piston moves from TDC to BDC. But how? In the power stroke, when the piston reaches in compression at the end of the compression stroke, when piston reaches to the TDC here, the TDC, then here a spark plug, as I've showed here before, before with you, this matches box, there's the igniter, and the igniter is this. That's how we ignite any matches. So here, as like this, inside the cylinder there is a electrical device, or electrical igniter. This is a wooden igniter, or wood igniter, as you can say that, or fireworks, firecracks, whatever you say. But here the igniter is an electrical spark igniter, which generate an electrical spark. When the piston compresses the air fuel mixture and temperature increases, and that time when the spark plug sparks, what happened, what we have studied: ignition, combustion, and explosion. If you remember that, then ignition happens, then combustion occurs, and as because there a high pressure and high temperature arises inside the cylinder, then explosion happens. And when the explosion happens, the piston gets some thrust on it, the top of it, okay, some thrust on it. And when the piston gets some thrust, it will create a torque over here, okay, a torque over here. The force will be just act the line of this connecting rod, okay, in this pivot, and it will create some torque or twisting force over the crankshaft, and with the help of this the crankshaft will rotate very fast. And when it will rotate, actual power, the engine gets, the actual power that the engine gets in this stroke. Okay, that's how the chemical energy converts to mechanical energy. Now the third stroke here is called the exhaust stroke. Now how it's work actually in exhaust stroke, after here an explosion happens inside the cylinder, then the air fuel mixture get burned and smoke occurs inside the cylinder. So you have to, get out those smoke from that cylinder, engine cylinder. So what happens when the piston, as you see in power stroke, when it gets a thirst explosion and thirst on the top of that piston, the piston will comes down very fastly, but it will not stop. Because why? Because the inertia, that the kinetic inertia that the piston gets, it can't stop here. It will go again, it will go, and it will just something like that. It's got a power and it will comes again because of the rotational power and the counterweights here. These are the heavier counterweights, okay, attached to the crankshaft. So with the help of this counterweight and for the kinetic inertia, the piston will go up again from BDC to TDC. Remember that the bottom was what is BDC. And when the piston will go up, the exhaust valve opens. Okay, when the exhaust valve opens, the piston actually, when the piston goes up, the smokes that occurs after the power stroke here, after burning up explosion over here, the product of the combustion, the chemical process combustion, the smokes gets out with the help of this piston, because this piston goes up and it just it just move away the smokes with the help of this exhaust valve, because it's opener. And that's what you see in the exhaust pipe, the black smoke that comes out, or the white smoke, whatever it comes out from the vehicle. So that's what the four-stroke engine works, and the next video we will talk about further about the four-stroke engine. Till then, stay safe and stay well.